Howdy, everybody in YouTube land. What we have in front of us today is a portable color television. Now, this was a VCF Midwest free pile acquisition. In fact, when the free pile was just starting to get going during setup day, I saw this. I'm like, why not? I mean, I can always use another hole in the head, right? So here we go. Now I don't know anything about this. We are missing a button on the side, but you know what? It was free. This is all we know. Let out smoke. Well, that's gonna interest. It's gonna make for a spicy video, I suppose. So, very little goes wrong with these things. I have not seen one of these that were in a failed state like this. I've seen little issues like dirty potentiometers or bad capacitors or something like that, but no actual failures of these little 5-inch color sets that are something like this. So I shall pull this apart. It feels like it's already wanting to come apart, like it's missing some screws, which wouldn't be surprising, but it's not that big of a deal. Also, it looks like it's a little bit yellowed. I don't know if you can see it in the camera, but it kind of has a gradient to it. Like it's more white over here and it's more yellowed over here. Like there's some heat concentration in this area, but I don't see any antenna. It's like, I don't know if this ever had an internal antenna. I feel like with the clip here and the way these things are designed here and here, that this was designed to be under the counter of a kitchen. So it was meant to, like, there was a bracket here and it just slid into a kitchen counter. So you could just watch your daytime TV programming while you're in the kitchen cooking your meal, I guess. I'm not sure. I never understood the point of kitchen TVs. I've never had one. And nowadays with open concept living rooms and kitchens and dining rooms like my current house is, you don't need a kitchen TV because the living room's right here. So anyways, beside the point, I'm getting a little bit on a tangent. All the knobs are there. Let's see what's behind this door. Oh, erase, add. So this is digital. It's got memory, but it doesn't really want to open, and I don't want to force that either because I don't want it to break. So the FM TV buttons are there. Those are the most important ones. This one's missing, but I'm sure it could be 3D printed, so that's not a big deal. Contrast, brightness, color, tint, all your general controls that would be on any TV of the time. So I am not plugging this in because of the smoke situation. I don't know, it could have a reefa capacitor because it looks like it takes AC and DC on the input. What it doesn't indicate, though, is it does not indicate the polarity. So I wonder if someone tried to plug something in here that was not meant to be plugged in here. All right, here we go. What do we have here? April 1992. Oh, boy. It puts it in that era. The leaky capacitor era. So maybe that's what's going on? Well, at this point, I'm just making assumptions because I have not taken it apart yet. Alright. Let's see how many screws are missing. Probably all of them. Nope, there's one in there. There is one in here and one in here. Now the screws are in there, so the screws are in there. Alright, well, here's what's funny. Date code 4214, but it's 92, not 94. Huh. I don't know. Everybody did things so arbitrary back then. See, how melted is the rubber? We're kind of getting there, but not. It's not quite there yet, but we're slowly making our way. All right. Let's see. Will that reach? Actually, it does. But I don't think it's going to turn that screw. No. We're going to need you. Not going in the hole. Can't find the screw. There we go. That is a really, really long screw. Those look special. So if those screws are missing, I'm not going to have that in my spare screw bin, that's for sure. So you're probably questioning why I'm even working on something like this. Well, let me answer that question by telling you that I don't have an answer for that one either. Because CRTs are basically dead at this point, with the exception of the retro gaming crowd or the nostalgia crowd. So, but this being so small, it's not like you're going to really do any kind of gaming on this thing anyways, unless you're just crazy. But, and you're not going to watch broadcast TV on it because there's no more analog broadcasts in this country and hasn't been since 2009. So, I don't know what someone would actually do with one of these. But for me, it's more of a novelty. It's more of a, well, I can turn this on and do my own OTA broadcast and use it as a toy, essentially. But other than that, as for any practicality purposes, this thing's useless. You can't really do anything. And then, of course, you could modify this kind of set and put like a multimedia player internal to it with Kodi or something like that built in, or maybe a digital converter box. You can kind of like make a fanny pack back here with all that integrated. But that would, again, that's more for a novelty, because the amount of power this thing's going to use compared to like a little LCD that does all of that built in is astronomical. Anyways, it's just cool, I guess. That's why. But also, for me, it's about preserving a part of history as well as knowledge. Because in a video, I can actually go through this thing and figure out what's wrong with it and fix it. And the knowledge is out there for other people to see for future generations. So, I just took it apart, and this thing surprises me in several ways. One, it's actually built relatively decently. It's not that incredibly cheap. I can't really tell who made this thing because it's a hodgepodge of parts. So, for example, the CRT is Onwa. I've never heard of them. The yoke is made by Samsung. The filter network for the IF is made by Hitachi. The jungle IC is made by Toshiba. And then we have another Toshiba IC just kind of hiding out down there. We've got a bunch of controls. Oh, we got another IC down there made by Onwa, which I've never heard of Onwa. I've never heard of them. We've got a bunch of Jamicon brand capacitors in here, which they're bottom of the barrel, but I've not seen one leak. So I don't think we're going to have any of that going on. But Jamicon is definitely bottom of the barrel. That's the stuff I've seen included with like Radio Shack kits back in the 90s. But I doubt that's going to be our problem here. But other than that, I mean, it's actually a decent set. We have the power supply board here with the regulator transistor for the power supply back here. Horizontal output transistor is probably there. Little tiny guy. But there's nothing immediately standing out on me. But it does have some hours, you can tell. But there's nothing, like, I don't see burnt soot or anything like that. I think the next thing I want to do as far as troubleshooting is concerned, I'm probably just going to test the horizontal output transistor to see if it's shorted. Because that's like, when it comes to working on CRT sets, that's my go-to. Is I check the horizontal output transistor before I even begin to apply power to this thing. The second thing I want to do is check the regulator transistor for shorts as well. As long as those two items are clear, I'll probably power this up with the 12 volt side only, skipping all of this down here. So that way I can kind of eliminate things out of the equation. Alright, so the first thing we're going to do is we're just going to take this power supply module out. Now I pulled this meter because that meter should be easier to see on this camera, and it is. So, now, I've not worked on one of these sets at all. I've never seen one. I've never worked on one. Nobody's ever brought me one to work on. Probably because most of this stuff was thrown away by the time I got into repairing electronics in the 2000s. So, alright. I want to get this out of the way because, like I said, the first thing I check when it comes to any CRT sets that have let out smoke or otherwise don't work, before I even attempt to energize them, is the horizontal output transistor. Now, this set has been unplugged for a long time now, so I'm not worried about charge or anything like that. So, the horizontal output transistor, I'm going to guess, is right here. So we're going to test U. Not shorted. Now, this reading is normal between base and emitter. And the reason why it looks like, oh, well, so someone can mistake and be like, oh, that's bad, there's a short there. But there isn't. And the reason why we get that reading is somewhere up in this chain is a horizontal drive transformer. Because the most televisions I've ever worked on, the way they're designed is you have the jungle IC, which generates the drive signal. That goes into a driver transistor setup, which is coupled into a drive transformer. It's a current mode transformer. That is then driving the base of this horizontal output transistor. So the most important measurement we need to look for is between base to collector, and it is not shorted. And then from collector to emitter, it's also not shorted. There's a capacitance there, so it's charging that capacitor, but it is not shorted. So we know that we do not have a fault, an immediate fault in the horizontal drive stage. And the reason why I check these is because if there's a problem with the flyback transformer, or if there's a problem with one of the secondaries on the flyback transformer, which feed things like the vertical output stage, the tuner voltages, and all the other voltages comes from the flyback, they're flyback derived. If there's a problem with that, there could be a current spike which can short the horizontal output transistor. So I wanted to make sure that there was no immediate failure in that vicinity. So can I rule it out? No, but I can say confidently that our fault's not going to be upstream of the flyback stage. So whatever we got going on is going to be in the power supply side. So let's check the voltage regulator. So we have a collector to emitter short, but that may be normal. So what we're going to do is unplug it from the main board and check it again. Okay, good. We do not have a short at this regulator transistor, which you can't see on the screen anyways. But our issue, let's see, the red, it's the black and brown wire, which goes between here and here. There could be many reasons. So, looks like this has been worked on before because I definitely see some resoldering job here. I'm going to take some quick dry measurements of this power supply module and see what we have in here. I don't have a schematic, I don't have a service manual or anything like that yet. No shorts. That seems suspicious, but there is a power transformer in the way. I don't like that though. I really don't like that. If I were to hazard a guess, pretty sure I found my problem. So with how big these diodes are, those are your bridge rectifiers, and there was a lot of heat. There's a lot of browning and heat built up there. So, is it possible to remove the power transformer? It doesn't have any plugs, so likely not. Now, if you go straight 12 volts in on this guy, which is right here, yeah, this is bad. There's a short on the 12 volt rail, literally coming in. Yeah, this thing is definitely, I found the problem. It's in the power supply board. So I can safely remove this board. So we're going to remove you. We're going to remove you. And then I can remove you, which is the IF input, or the tuner input. And I can also remove you, which this is not super important, because this is UHF. UHF will never, ever, ever be used again, ever, unless you're running your own rig. And I can safely take this guy and move it out of my way. We know the problem is not in the CRT section. Probably. The problem is going to be in this section here. So the next question is, how do we remove this? Well, we'll start here. I'll remove the regulator transistor. We'll remove the 2 screws that go into the heatsink, which also thread through the transformer and into the plastic housing. Now, the smoke could have very well come from the power transformer. It could have very well come from the power transformer. So, okay, that's out of the way. That is a 2SB943 from Matsushita, aka Panasonic. And that is now out of the way. Alright, so this is fun. How am I supposed to remove that? Who does, really? 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 Okay, so that means we're going to have to unsolder some things. Well, it's out of the way enough. Wow. Wow, wow. Look at this. That diode is split right down the middle. Wow. So whatever happened to this thing, I wonder if, you know what? Hold on. No. I wonder if that big cap shorted. So we've got blown bridge rectifier. Look how big that bridge rectifier is. This thing doesn't use that much power. That one's okay. That one's okay. That one's not. That one's definitely not. And this one's got a nice big crack right in the middle there. So we're going to need to remove these diodes and get them out of the circuit. Let's see. Let's check this. Let's see. What is this resistor? 6.8 ohms. Let's make sure it's not open. No, it is not. Alright. This one is a 330 ohm. Not bad. Transistor here. Here, let's see, what are you? You are a 2SB945, which is a PNP. And I've got nothing. I've got nothing. Actually, no, there we go. No shorts there. Fuse. Fine. Fine. Let's check the primary winding of the power transformer, which is going to be hard to do with the diodes in circuit because it goes across. That might be alright. Okay. Well, actually, no, that's the secondary. Now we need to check the primary right here. Yeah, transformer might be alright. So the let out smoke is likely from this bridge rectifier right here because she's got a nice big split in the middle. We need to remove that. We need to remove all of that. We got to check that stuff out of circuit. So let's do that. Just to get an up close shot, look at this. You can see that split right down the middle. Yep. Alright. This went bad, but we still don't know why it went bad. The only thing we can do is pull those out, make sure this capacitor didn't short, because that'll be a, yeah. So remove those. Anything else? And these have been reworked before, because you can see the solder joints. So this thing had a problem in the past. But my lord, look how big those diodes are. That's insane. And they still blew out. Alright, so got that resistor out, or diode. Let's see. Let's make sure that one's bad. Because I see a crack, it probably is. Yeah, that sucker's gone. I'm gonna leave you out since I know you're dead. That one's okay. I only lost one. Let's check this cap. Yeah, why am I not surprised? The capacitor is shorted. I can't get away from capacitors. Good old Jamicon 4700 microfarad 25 volt Wonder Muffin. Let's make sure it is the capacitor. I could be prematurely saying that it is, because it's easy to blame caps, right? You tell me. Pretty shorted. There's why the rectifier went kaboom. So someone just like plugged this in because it was in their grandma's basement for 20 years and said, hey, let's see if this works. Nope, doesn't work. That's also a problem too. Actually, there's a jumper lead through here. So you're connected to this resistor. That's a Zener diode, but I don't know its value. I'd have to pull. Well, hold on. I have a thought. Because there's a 10 ohm resistor right here. Yes. Let's check the Zener. Ooh. 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 No. 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 That's also fun. This thing is seen. I don't know. This thing got like instant destruction. Is that a resistor? Wait a minute. Wait a minute. That might be a resistor. That is the weirdest looking resistor I've ever seen. I've never seen a resistor with a band on it. There's no way that's a resistor. It's in the spot where a resistor would be. I'm gonna remove it because I got to figure out what that actually is. It could be a resistor, but I've never in my life seen a resistor in the form factor of a diode. That certainly looks like a diode to me. It's probably a reverse protection diode. 1N4001. That is not a resistor. That is a diode. That is a diode in the spot where the resistor is supposed to be. And it's a good diode. Yeah, that diode's fine. Alright. That's expected behavior. That should also be. That's right. So let's make sure there's still no short across the B plus here, and there isn't. Let's check everything else. That one's okay. What value? 2200. I swear, since I've already seen one that's shorted, I should just change them all because, yeah. Alright. Okay, now we've got a Zener diode here we need to check, which is part of the regulation circuit. I can't tell if it's good or not. Seems to be. This one has got a couple of diodes here, and it's got this same hydroscopic glue. These are standard diodes, 4148 style. Fine. Fine. Okay, those are okay. That's it, really. Let's check this cap here. This is a 3... No, that's 1000 at 25. It's okay. But being... Oh, that's Nichicon. I'm inclined to leave that one. This one's going. These two are going. And I gotta find something the size of China to put in there. Alright, there we go. Alright, so this black glue is the same type of stuff as that yellow glue. Hydroscopic, because I just scratched it off and it's eating the crap out of the diode pins. So this black glue's got to go too. Because it's just, yeah, that's not going to work. The fuses are also original and their correct value. But yet it didn't catch that. I bought a big bag of diodes from an electronics closeout sale. It was probably the best thing I could have ever done, to be honest, because I've got every diode under the sun in here. I don't know if I have that one. These are 6 amp 100 volt. A little smaller than those. P6600, that's 600 volt. I don't need a 600 volt diode, because this does not run at 600 volts. This is 800 volt. Ultra fast recovery. So these are power supply diodes for switching power supplies. I got so many. Here's a Sal's capacitor thing. I have no idea. I like how the diodes are individually bagged, so that helps tremendously. 1000 volt amp. I tried to consolidate all the diodes in here because, yeah, let's see, 1000 volts, 800 volt 6 amp, 50 volt 6 amp, which I don't know if that's what I need. I figure maybe like 2 amps, 3 amps, we'll see. We'll see how it works. The downside is this is going to be different from the rest of them. I kind of wonder if I should just change all of them. Anyways, we'll make this work. I still got to look in my stash to see if I can find that diode or something close to it. But all the caps are replaced. The unfortunate thing is I did not have any 4700 microfarad caps at 25 volts. So I'm going to have to order some of those. But because I don't feel like ordering caps specific for this TV because it's just not worth it for me, I just grabbed a couple 2200s that doesn't fit anything I have and just shoved those in there. Just bodged them in. They'll clear. Are they perfect? No. But they'll work. So, and since most of the caps I have are low ESR, low impedance, that's what I ended up using in there anyways. Which may or may not work right for a linear power supply, but, well, it's what I have because I tend to work on switching power supplies more than anything. So I got to go through my stash and see if I have a diode that's close enough that'll work in there. Now comes the fun part. Does it work? Here we go. Oh God. Does it work? It does. It's working. Well, I love that. Oh man. That's nice. That's nice. So we actually have snow on the screen now. And it's actually on. I don't know. Let's see. What are the settings here? Contrast, brightness, color, and tint. So contrast, brightness, way out there. But yeah, there we go. It's working fine. Let the smoke out no more. There it was. That's all it was. Capacitor shorted. Took out the diode, which then didn't take out the fuse, surprisingly enough. But it works. So now we got to get this thing set up with a signal. So stand by, because it's going to take a minute to get ready. I didn't know Microsoft was here, involved in this TV. So I've left this on for a bit, just with a static screen. And the regulation circuit is working because all these components are getting warm, and this is slightly warm to the touch. So this is a 12 volt input anyways. So there's probably not much there it's regulating, but the regulation circuit is working. Now the damage was in the transformer side, which I have not tested yet. But I know the 12 volt input side works. So I'll get to that in a bit. But for now, I want to get an antenna connected into it so I can get a signal in here and see to make sure the rest of the circuitry is functioning properly. So in order to do that, I need to fire up the OTA modulator and the equipment so I can get a signal in here. Alright, antenna's connected, transmitter's on. Let's see what happens here. Okay, so we gotta go back the other way, because channel 6 is where it is. Oh, we're there. Kinda. Signal isn't very strong because I don't have the power turned up on the transmitter on purpose. Because the last thing we need is, the FCC banging down our door, right? Crap. Come on, there's too much crap up here. Oh, there we go. 4000 just booted. I still thinks it's raining. Oh, there's no internet on that 4000. Interesting. It didn't fire up the... Anyways, probably not super important. Oh, there's the color. Color control's kind of working. There we go. So there's the tint. Got to get that set right. And that's kind of where it's supposed to be. Color should be somewhere around there. Something like that, I think. I don't know, we'll see. I don't like how the antenna isn't working very good. But the last time this 4000 was turned on was when all of the hurricane was here, when the power went out. So the data, it looks like it just got hit with a refresh. So it's on. It's working. Kinda. Signal isn't very good. I need to go check the RF level. It generally isn't that bad. But anyways, hey, it's working. I got a picture. All I got to do is hook the speaker up to it and check for sound, because I think I have the music playing in the background too. I'm gonna throw up flavor J. It should go. Yeah, there it goes. Okay, that color definitely looks right. I don't know if it's 100% right, but it's right. Yeah, that's about right where it's supposed to be, right there. The color control is not very responsive. I do know that. But yeah, that looks about right. Just kind of a noisy picture. I don't think that is normal, though. There's something going on with that. But that's actually really good. It's coming in well as far as the color is concerned. You know what I think it is? I think it's that. That thing puts out a ton of noise. That cheap Chinese piece of crap switching converter puts out a ton of noise. So now is a perfect time to check the AC input to see if it works. So I'm going to go grab a power cord for that. Hopefully this old boombox cord fits. It should. Get you out of the way. I think this is the right one. It is. Because a lot of them, the newer ones now have like a little cutout in the middle. The little V-shaped cut. This one doesn't have that. So here we go. It's either going to work or blow up. Is it going to work? Okay, it's on. Yeah, see? See what I mean? Much better. Yeah, that's much better. It's that stupid switching. Ugh. So I bought this for the prison book. And it's garbage. Does not, you know, to be honest, if I took this apart, this probably does not have an EMI filter built into it. And that's what happens when you don't have a good filter. So, all right, we have a good, get the tint adjusted right, which that looks about right. Yeah, it's working amazingly well. Much better. Much, much, much better. Yeah, I've had this thing on for a while now, a couple hours at least. Audio's working fine, everything's working fine. Let's see. Radio works. So that's good. I think that's going to do it. It's all back together. It's running off the electrical power cord. And there's been no more issues with this TV set. Oh, besides, you know, that. Got my little plastic scraper tools so I can get that label off that was on there. And that's taken care of now. It's clean. Everything works properly. So that was a relatively simple repair. Hopefully you all learned something from this adventure. So there we go. Troubleshooting a TV from pretty much the ground up at that point. Fortunately, it was a simple fix. We didn't have to get super crazy with it. Now, what to use it for? Good question. It's more of a novelty, but at least it's a novelty that works. So if you enjoyed this video, don't forget to hit the like and subscribe and all of that fun stuff. Feel free to leave a comment if you have one. Until next time, guys, thank you for watching.